So we know it's
Yep.
going to be a really good show today because we have two Ians. So double the Ian, double the fun, I'm sure. Um, it's a pleasure to kick this off and provide an overview. It's a fairly high level overview talking about why we got into this in the first place and again at a high level pointing to some of the things we're doing. Then I can hand off to my colleagues for a bit more technical details. I should also say that tomorrow at 6:30 p.m. European time is going to be a session on the Geo In Situ working group strategy development. I'll be presenting that as well. And the focus of that one will really be on providing input and suggestions, recommendations for that activity from our community to suggest, where they can go. So there's still time to modify my messages, so I'm really keen on seeing what we get out of the conversation here, see if there's anything additional I can bring forward to that discussion to really help the broader Geo community. So with that, Sven, can we go to the next slide? I guess not. There we go. So why us? Why is our community so interested in situ data? Well, really, we have a lot to gain. We're a global community of scientists. Many of us both generate in situ data and use the in situ data, and basically the entire activity realm of activities that we do benefits from its availability. We have extensive partnerships, way over 100 institutions contributing around the world. And we have a lot of expertise embedded within that. Also not just expertise, but we have a lot of projects and activities that can leverage ongoing activities, ongoing investments to make quick, meaningful progress. And that's what we're really trying to do here in this activity, which we just kicked off this year. But we're trying to make some quick wins, quick gains as we go forward. And we have experience. So GeoGlam is now a little over 10 years old. JCAM, our research network, actually predated GeoGlam, so it's well over 10 years now. Quite early on, we were developing standards around field data collection and so on. So we do have some experience in this. Next slide, please. So as our community, we've been talking about in situ data for a number of years. We weren't quite ready, mature enough perhaps to really take it on because it is such a large, challenging task. And as we see how things have evolved over the last decade when GeoGlam's been around, we see that initially the biggest constraint to global agricultural monitoring was access to free and open EO data. And that's been largely taken care of by Copernicus and Landsat and other open data sources. The next major hurdle was big data analytics, computing horsepower, if you like, and we've seen a proliferation of cloud computing platforms that have largely addressed this. And then the next constraint was access to mature, reproducible analytical tools that were openly available. And in the last few 4 or 5 years, we've seen a big move in this area. Probably the best well-known one is the situ toolbox, openly accessible. So that leaves us with really the perhaps the last frontier, which is open access, and by that I mean the last frontier to broad scale, reproducible EO data, being enabled for our uses. And this is the open access to high quality, well managed in situ data. Next slide, please. So a little bit of the context. We've had really strong support for this activity within the community. It is the most enthusiastically embraced activity that GeoGlam has taken on in terms of a working group activity. We're going to start by taking care of data collected by GeoGlam partners for the most part, and also identify sources that may be out there that we can also access easily. So as I said already, building on existing activities. We're going to start on a measured way, trying to take on something concrete. So we're trying to do real things, building on these existing activities, and then tackle issues, not just data. Eventually, we want to have a comprehensive approach to strategy, guidelines, best practices, as well as the infrastructure to maintain and store and processes within our community. A lot of this, though, does not have to be restricted just to GeoGram. I think there's a lot that we can look to the broader geo community to develop common infrastructures and so on, and talk a little bit about that. And as I said, tomorrow we'll be talking more about that. So a community approach, we really want to build the culture of curation and open sharing, open by default as much as possible, and at the same time developing guidelines for assessing and comparing analytical products, which I won't talk about today, but it's kind of a companion piece to this because of the proliferation of analytical products, and then assessing in situ data quality, which Arun will be talking about. Next slide, please. So I think Sven already did a good job of outlining this. I got a couple slides to finish off after this about the data lifecycle management process, kind of our strategy approach. I'll talk about. Hendrik's going to talk about identifying and managing what is already available, building on work in the World Serial Project to create a global reference database. In situ data collection tools will be discussed by Ian, and then Arun on quality assessment. Next slide. So this is what we mean by a data lifecycle management system that we're looking at. The EAV gaps kind of starts down there. That EAV is the Central Agricultural Variables. That's another activity our community is working on, and that's driving a lot of the user needs. In turn, this moves into the plan, develop, document, and these activities are often done in projects that are various funders support to help support the GeoGram activities in part, and even broader often. Our community is looking at a way to actually endorse data sets, whether we want to do this, and if we do, what's the process to get that done, give it the good housekeeping stamp of approval, if you like. And then those blue arrows on the right side are related to accessing and managing the data, technical infrastructure, if you like. And it's something that certainly the GeoGram Secretariat is looking at first, but this is in particular an area where I think as a broader geo community, we should be looking at possibly partnering on. And then to complete the circle, we need to continually review the data, ensure its relevance and accuracy is still meeting the needs, purge what's not, refine what is, and also refine the user needs, because as we know, the policy drivers that we're always trying to address continue to evolve, so our needs will can be expected to evolve over time as well. Next slide. This is the last slide for me. So if you look at the left side of that life cycle, we're focusing on addressing needs driven by EAVs. As I said, the initial ones we're looking at are very relatively simple for our community: crop type, crop area, and phenology. And the reason we're looking at those, they are simple, we can make quick gains, but they're also associated with eShape and World Serial projects that are doing work in this area already. So the types of minimum data sets that we expect to come out of this, probably even simpler than this list, would start with things like crop type, land cover, phenology, and so on, and then get into more challenging variables as we go over time. We're inventorying the gaps in the World Serial and the crop type and land cover and eShape on phenology. Then the infrastructure to support data curation, and that's where I point to the right side of that diagram. Again, just highlighting the fact that this is an area where I think we could think about creating a data curation hub, perhaps building it on top of the GeoKnowledge Hub platform that is now in development, and could include things like access to documentation, data visualization, metadata, and so on. And with that, that's my last slide, so I'll turn it over to Sven and the next speaker.
Okay, thanks Ian. Thanks for that very nice overview. just for people that joined a bit later during Ian's presentation, there's two ways to ask a question. You can either put it in the chat or raise your hands. For sake of time, we said, okay, if you want the raised hands, we will keep them until the end of the session so that we can have a discussion after all presentations. Except if you have a very, very urgent question, you can ask it now. If you have something really urgent, you can do it now. And otherwise, we can move to the next presentation of Hendrik Bogaert from University of Wageningen. And within, well, I know Hendrik for quite some time now. We've been working on on quite a lot of projects together, and he will be giving the overview of what we're currently doing within World Serial, and even a bit more, even outside of World Serial, on the global reference database. So, Hendrik, the floor is yours.
Thanks, Sven. So I will talk the next 10 minutes about this global reference database, the status and the prospect within that World Serial project. So first, let me introduce that World Serial project. That's on the next slide. So the World Serial project, you might have heard about it. It's a project of 2 years where we are prototyping and implementing an open system for producing different products around cropland mapping. So the annual cropland extent map at 10 meters resolution, taking into account also the seasonality. So producing such cropland extent map right after the season. Also making a distinction between rain-fed and actively irrigated cropland. And on top of that, also crop type specific maps, specifically on maize and wheat at the same resolution, 10 meters. So that's the World Serial, and you can find more through that URL. But yeah, to do this and to train these crop classification algorithms and to validate the maps, you need sufficient high quality and preferably what we promote public data on land cover, crop type and irrigation. So for both training and validation. That's a kind of introduction to this reference database that we are then building within World Serial. So next slide. So, and then you have to conclude that in situ data that we need, or reference data, if you can call it also like that, is quite scattered in our domain. So I just made a kind of overview of different sources. Like you can think about portals like the CGR, so the consultative group of international agricultural research institutes. They have a portal called Guardian where you can find and access data sets. The Copernicus in situ initiative, access to observation networks, but also spatial data through Corda. All these links are on the slide. I guess the slides will be sent to you after the meeting, so you can also check these links. Data repositories, because the portals are more access and search engine, but the data is then stored in data repositories, like for CIMMYT and CGR Institute. They have the specific repository where then you really find the data. But you can also think about open data journals like Earth System Science Data, where CIRAD, one of the GCAM site partners, have published the data, or ODJAR, an open data journal that's being managed by my colleagues, where you can find more data around field experimental data of crops, but also peer-reviewed papers, specific initiatives like long-term experiments. Radiant Earth have their machine learning hub specifically on training data for crop mapping, giving the combination of an imagery and label data for specific small areas where you can then train algorithms. But on phenology, there's a European initiative, ACMIP, more in the model, the crop model domain, and so on. And also specific projects, like we found data for World Serial in the Tanzania Soil Information Service, where they did a field survey. So it's really scattered. And next slide, please. And we must conclude that on the right, you see this FAIR scheme that you probably know. So about findable and accessible, interoperable, and reusable. So the FAIR. So generally, data are findable through these portals, and mostly also the data are accessible and you can download it. But in many cases, also there are restrictive data policies that can only be used for research and education, not for commercial use, or you're not allowed to redistribute that data. But I think the big but is that it's not really interoperable in the sense that you cannot easily use it for your own purpose. So there's a clear need for data curation. And that is for instance, on the interpretation on the accuracy or the meaning in space, time, and theme. I have an example like you can think about an observation network in Germany, where they have really observations of phenology, and they give the location, the station, in very precise coordinates. But and then it's the observation of flowering of maize. But in the end, it's not that specific place. But in the instructions or in the methodology, it's that it's the center of the village or the church, where the people that is doing the observation is instructed to look at the most representative field of maize in the area of 5 kilometers. So then the spatial accuracy is not that specific spot, but it's actually has an accuracy of 5 kilometers. And the same you can think about for our crop type mapping if you need information about the timing. So you really need to know when the observation was done, because you want to connect it to the sentinel imagery. Then, for instance, an observation where you only have the year in the Netherlands for sugar beets, it's okay. I assume then it's June. I can say, well, in June, I know sugar beets are there. But in Kenya, maize, and you only have the year, then you have a problem because it's the short or the long range. So also in time and also in more thematic, what does the crop description means? You have to translate it into a more common legend. Similarly, more technically, the conversion of formats, units, definitions, and in the end, this data creation is really tuned to a certain objective, like crop type mapping in our case in the World Serial. So that is a real issue, that you really need to do that data creation, and not easy to do that, and also I think impossible to do it in an automated way. You really need to go back to the background documentation to better understand the study and how it was collected. So what we have done in World Serial, we are sourcing from existing data, like you saw in the previous slide. So the acquisition, harmonization of existing data through our partners network and the main stakeholders in our domain. And we're also connecting to the ongoing and newly initiated field surveys. But I have to say that in World Serial, budgets for real doing new field surveys is very, very limited. So really rely on existing data, preferably recent, since the Sentinel era. So that is since 2017, I would say. And then we distinguish different types of observation data. So field observation survey, so really an observation in the field. But we also have, through our partner IASA, another type of source where you look at already a classification, but then it's checked by the crowd or by an expert, like the known, probably you know, GeoWiki or LacoWiki. So several experts or several persons are checking then that classification and then agree on that classification or disagree. In the training, you can also think about using classified maps in the end to do the training if they're really good maps. And a fourth category is the formal declarations, like in the European Union, the ELPIS, so the parcel registration. So these 4 types we do distinguish in World Serial in our reference database. Next slide, please. And then, the real work is after collecting that data, is reformatting into a predefined format, mapping it to the World Serial legends on land cover, on crop type, and on irrigation. And then also working on that the timing, the validity time. We need a real date. So we need, if we only have the year, we work with crop calendars, and then we say, well, that is the central part of the crop calendar, the central data that we use for our date. Usually we do have the real dates, but some occasions, for instance, the ELPIS data for Europe comes with a year only. So we have to make a decision there to translate it into a real date. Then we also assess the quality. That helps us to select and filter the data in the training and the validation. And Arun will tell more about that, my colleague. So I will skip that one. And of course, the metadata, so that we make a complete description of the data set before we publish it in our reference database. So next slide, please. The next, yeah. So here's an overview of what we have collected in World Serial. So the red areas is where we do have data. So it's in Europe, it's in Africa, a bit in India, in South America and North America. And it comes from various sources that you see below at the bottom of the slide. Different projects, but also the ELPIS data, for instance, and a classified map from the USA, Radiant Earth, all kinds of different sources. You also see that it's not nicely spread over the globe. So that's the next slide, please. First, in tabulary overview, you can see on the top left the land cover, and we have around a bit more than 90,000 observations. Focusing on annual cropland in the left table, we have half of that observations relates to annual cropland, for instance. On the right, you see the crop type. So we do have quite some observations on wheat and maize. Maize is 1/9. Wheat altogether also 1/9. But for instance, spring wheat is very minor, only 500 observations. Well, we would like to distinguish between those. So, and on the irrigation, we do have quite some number on the rainfed, which, yeah, you want to make the distinction between rainfed and irrigation, so you need both. But it's not nicely spread over the world. I think on the next slide, we have 2 maps on that. Yeah, so on that right map, you see the irrigation, and it's only Spain, Morocco, and a few spots in Africa, Egypt, and Madagascar. And the spring wheat on the left, some data in Europe and in Northern America. So we conclude that we have quite some gaps in South America, Brazil, Southern Africa, Central Eastern Asia, India, Australia, and what I already mentioned, spring wheat and irrigation. The other thing I want to mention that besides we collecting and harmonizing data, we also make protocols on the formatting, on the mapping, on the accuracy, which Arun will talk about. So that's a bit about the status so far on our reference database in World Serial. Now, a bit looking to the future. In this project, we continue our research. We are in the middle of the project, so finalizing the first year. Strengthening our network and collaboration with GeoGLAM, NASA Harvest Initiative, the Copernicus in situ, CGR Guardian, Radiant Earth, FAO, but all other dedicated projects that are ongoing. Well, if you have suggestions, there is this link to our questionnaire that you can describe your data set that you think would be valuable for us. Yeah, we really emphasize and stimulate sharing, and I think there are different incentives to do so. So if as a researcher you have your data, you become more visible if you share your data. You will have attribution. It's also kind of social responsibility to share your data if it was funded by public tax money. And through the World Serial, we try to ease the sharing of the data. So we work on protocols, easy upload to our World Serial system. Altogether, I call it phase, so a nice phase with flowers. So we offer a simple and guided data upload to World Serial that's being built. It's on the mapping to our legend, the World Serial legend. It's on helping you to define the right timing, on the metadata, on the accuracy. And even looking beyond World Serial, I think we need to further think about how can we institutionalize this reference database from World Serial, for instance, in the GeoGLAM. So the host of the reference data, a more formal status beyond that project level. And yeah, this is kind of dedicated solution, this reference database for crop type mapping. I think we also need to think about more general interoperable database solutions to store and manage curated data around crops observations, because World Serial is mainly about, yeah, it's crop type, so only the location and the time and the crop. But for instance, AgroStack, it's on the next slide, I think that's the last one. We have a kind of solution which we call a global crop trial repository that's going beyond crop location. So it's more than only crop location. It's about phenology, yield levels, leaf area, everything you can measure around the crop, I would say. But we like to focus on the minimum data set to serve the most needs. And yeah, it's focusing on field survey data. It's an initiative by our Wageningen University and Vito to stimulate exchange and use of these key crop observations. Currently, we have data from ODJA, this open data journal, and a few more in our AgroStack infrastructure. And I think the key characteristics of this solution is that it's a very generic, flexible data model. So it can tackle all kinds of data around a crop. So it's not only for crop type or only for biomass, but it's very generic and can deal with many different data types on the different domains. But we're focusing on crop, and so we have a kind of infrastructure that works, but still needs to grow in terms of data. And that could be a solution also if you're thinking about going beyond crop type and also beyond the project level. So that, I think, was all I wanted to share on what we did in World Serial on the reference database. Thanks for your attention.
Okay, thanks, Hendrik. Thanks for this nice overview. I think the question is clear. If people around the table have good open data sets, in situ data sets on spring wheat or whatever, or irrigated, non-irrigated, there is this link to the questionnaire where they can fill it in, or they can contact me or Hendrik to see how we can set up sharing, and that will flow into that GeoGlam infrastructure as well. So it's open and free. That's what we're advocating. And if you don't have data to share, but you're willing to collect already something, then we can move to Ian's presentation, who will give a nice overview of what they're doing at the ASA side on crowdsourcing information, but also on in situ data collection tools. So Ian, if you're ready.
Yes, yeah, great, thanks a lot, Sven. Yeah, I'll try to speed up a little bit just to save us maybe a few minutes at the end for questions. So yeah, great that we have two Ians in this talk, two Canadian Ians too. That's really amazing. That doesn't happen too often.
that only lifts up the level even more.
Incredible.
It's amazing.
It's a lot to live up to. Yeah. So yeah, great to see lots of familiar names and the call, and thanks Sven and Ian for organizing all of this. And just going to speak very quickly on some of the in situ data collection tools, in particular this GeoWiki platform, which we've been developing here over the last decade or so. And I'm representing our group on research and development, and my colleague Stefan Fritz as well. So here is just a screenshot from the geowiki.org page. You're very welcome to go there and have a look at it if you haven't looked at that before. This is something we set up about 10 years ago to sort of address some of these data gaps that Henrik was just mentioning earlier. Our main focus at the time, really, what brought us into this was the issues that we were recognizing in terms of global land cover, land use data sets. So the discrepancy between the available data sets as new data sets were coming, and in terms of the effects that was having on the modeling work that we were doing at EASA, the global land use modeling that we were doing here. Depending on which data set you were taking, of course, there were major differences which had then knock-on effects in the model results. So cropland extent being one good example. There was just very large discrepancies between the MODIS, the American products, the MODIS products, the European products at the time, and they still exist. So we set up this platform, and we still are running various types of campaigns. Next slide, please, Sven. So tackling lots of different issues here, and I just have a few examples of how this is sort of basically how it's looking. This is one of the things it does. It's developed into, it has many different functionalities meanwhile, but if we have a sort of a specific, we run a specific campaign where we want to use high resolution satellite imagery, then it might look like this. This was something we did on global field size a few years back, where we're dropping a grid on top. So we have a sample design, and then we have a grid, and there are some questions that that a user can go in and answer for us. And so visually interpreting high resolution satellite imagery, which we're pulling from various sources now, Google, Bing, and others. Next slide, please, Sven. Yeah, so and then this is coming a bit closer now to cropland in particular. So we also had campaigns set up to do some cropland validation. So one of the things we were focusing on a few years back was actually cropland extend. We organized some large meetings here at IASA, actually trying to pull the community together, and we're running specific campaigns. And again, this is just an example of some of the tools that are available within this GeoWiki system. You can draw on time series data to present things like NDVI to the person who's doing the crowdsourcing, with a variety of other tools. And then you've got, again, high resolution imagery, and we ask a variety of different questions. And this has been very successful. I have some results here. Next slide, please. Over the years that we've been running this. So this was one of the products that we put out a few years ago on global cropland mapping. So this was a campaign that ran for about 3 weeks, and we had 80 participants, 144,000 observations, and about 36,000 unique locations. So we're then very often in these campaigns, we're sending people, more than one person, to the same location, obviously to give us some indication of the consistency and the agreement between the users. So we also tend to, with these kinds of campaigns, we actually do have some training components built in. So we really try to educate the people who are doing the crowdsourcing at the start, to get everybody kind of up to speed. And then we do have sort of checks as the campaign runs. So comparisons with expert evaluations to kind of understand and monitor the accuracy and try to sort of steer the crowd. So all of this data, we're trying to really publish this, make it openly available. So putting it on repositories. This data is on the Pangea repository, and also publishing papers describing also the data and the methods. Next slide, please. Another example we have of global field size, which we did more recently. This has also, again, been published and data put on a repository. So this should all be discoverable, all of this data. But again, as also Henrik was alluding to, yeah, the data is, of course, scattered. So it's we're making it available, but there's still a lot more work to do in the curation and being able to pull all this data together, of course. But this was also a very successful campaign. Here, 130 participants with an even larger amount of observations, sending people at least 5 times to each location, different people, to really have a comparison of people's validation quality at these locations. And this data set was quite interesting, because we were able to really adjust the sort of understanding of field size. So in particular, so small field, very small and very small fields, we increased the number. So the percentage is about 40% of the global agricultural areas in very small and very small fields. And that was quite a jump up from what was sort of previously understood in this. So there is some also some interesting results that come out of this type of work, and this kind of work is also very useful in a lot of the modeling work that we do here as well. Next slide, please. Yeah, so moving now a little bit to something slightly different. We are working, also participating in this Global Earth Challenge that was being run out of the US in the last years, actually during this whole Corona period. And this is capitalizing on something we developed here called Picture Pile. So this is a little bit different now. Now it's a much more simpler kind of a collection tool, something that can be done on the mobile phone, for instance, and kind of just providing, in this case, street level imagery to people and asking questions, in this case, about crop type. So we've had over 600 participants in this, with about 76,000 observations coming in. Next slide, please. yeah, so some initial results from this. So we were actually then comparing our the data we received from the crowd with land parcel information, and actually had very good agreement. So quite surprising here. But again, there was quite some training of the crowd in this, and some quality control throughout. And we kind of selected crops in particular, which were, which are relatively easy for people with some training to detect. So wheat types, so lumping all of the cereals together, sunflower, vineyard, these sorts of things are making it a bit easier for the accuracy. Next slide, please. Yeah, and so just to mention here too on some of the work we're doing together with the colleagues in the World Cereal Project. So we're looking here now at street level imagery. So we've done a lot of work in the past with satellite imagery and high resolution satellites, drone imagery, now starting to move also and combine this with street level imagery, which is quite powerful actually. So putting these various tools together, and you see here just this one application that we're building in the World Cereal Project to collect additional in situ information. Next slide, please. And so this is being driven by actually the availability of street level imagery over the globe. And everyone probably is aware of the Google products, but there are also now there's an open source product which is coming from Mapillary, and they have actually they have better coverage in some of the developing countries. So this is what's helping us to feed this application. Next slide, please. But one of the issues with a lot of this data is that you don't really have the temporal component there, and you of course, because you're not really in the field at that location, it's also, as Henrik was mentioning, this is a lot of the information that we need is actually lacking. So it's a lot of this data which I've been showing you here previously is very complementary to a lot of the needs, but we recognize that we also do need some real in situ with information on crop type, on phenology, on management practices, with a time component. So we've been in the eShape project now together with colleagues in the showcase on agriculture, developing this mobile application where anyone can download this, go out and collect very basic data on crop type and phenological stages, etc., and upload this information. And then the plan is to put this into AgroStack and also make this data openly available. So I think we have a prototype already developed, and in the next weeks we should have this out and running and available for download. So I'll conclude there, and thank you very much. Thanks, Sven.
Thanks, Ian. Thanks for that nice overview. It was quick. There was lots of information in there, but thanks a lot. You mentioned quality. That's really important for the in situ, and quality can be described in different ways. Quality is also depending on your the end product that you need. For mapping, you might have different quality needs than for just monitoring. And that's something that Arun will discuss. Arun, also from the University of Wageningen, and our quality expert in the GeoGlam in situ data working group. Arun, if you're ready, I think you can go.
Yeah, thank you, Sven. Good morning. The last presentation on the quality. That's good. So let's just start without losing any time. Can you go to the next slide? Yeah. So as we heard from my previous presenter, that data are really growing. Also, if you see the open data publications, number of policies, movement, journal requirements really ask to publish their data open. In agriculture, we have also this GODAN, Global Open Data Agriculture Initiatives, and countries are more and more participating in open data. You can see this map where the map is described about open data barometer. It shows how countries are really publishing their data for accountability, innovation, and social impact. And we can see from the map that there is quite a bit green countries. That means countries are slowly doing better in data publications. From a research side, as we heard in the morning presentation, that there are many research institutes are opening their in situ data. For example, Guardian, Radiant Earth, GeoWiki, and others. Next slide. But still, the problem is reusing of existing data is fairly challenging. There was one Nature blog which was describing that only 5% of existing data is really in use. And why is that? So it is mainly because of lack of confidence in data collection procedure, because scientists didn't believe that the collection procedure was right or is not fit for their purpose. Second thing is data types are generally heterogeneous in nature. Each of these data have their own sampling design, acquisition method, and format. And it is challenging to really combine together. Also, the accuracy and reliability of each of these data sets are often questionable or different, and it's difficult to merge together. And finally, the trust and credibility of these data sets are very difficult to merge and have one data set. So, next slide. So in the that's why within this World Serial project, we try to develop a generic scheme to calculate the confidence score of these heterogeneous in situ data set. So what does it mean? That we acquire, as Henrik explained, we acquire almost like more than 90,000 observations or data points from different data sets, and we try to merge and see how we can assess and do the quality. And the scores are derived based on the three quality criteria. That means the spatial, temporal, thematic. That is essential for our crop mapping work. And third, although the project was, though this exercise has been done in World Serial project, the concept presented in this quality assessment is broader, and it can be applicable to the broader research domain. Next slide. Yeah, so we use 4 data sets, as Henrik mentioned in his presentation. So we had a field observation, a windshield observation, a classified and validated map, GeoWiki, LacoWiki, automated classification, that is classified maps, and for formal declaration, parcel registration. The pictures below shows all this. Okay, next. It's okay. I think I can speed up here. Next slide. Yeah, so if we see for the in situ data, the ISO have these 5 key quality elements. That is completeness, logical consistency, spatial accuracy, temporal accuracy, and thematic accuracy. Often completeness and logical consistency is more or less okay. So next. So in this exercise, basically within the World Serial project, we basically focus on these 3 elements: spatial, temporal, and thematic elements, and we try to come up with the average confidence score that can be derived from these 3 elements. And then each of these elements have different categories, and we assign different weight. At the end, we sum up and come up with the one average score. And that's the formula I showed basically. Yeah, next slide. Yeah, so how we're calculating the spatial accuracy? Because it is very tricky. Once we acquire the data, most of the time the data have not reported their GPS accuracy or error in the recording of the GPS location. So within this project, we look at it first, whether the geometry of the provided data set is raster or vector. If it's raster, then we look at it the pixel size or grid size. The picture shows like the raster, the unit of pixels. Where in the vector data set, we try to look at it, where are the data coming? So map it and see the contextual information, that is, it is near the road or near the park or near the river and so on. Next slide. Yeah, and based on that, we have developed multiple level of assessment categories. So level 1, we really benchmark this reported locations with non-arrayable spatial features and infrastructure. So how we do it? So if we receive, for example, the map right-hand side, so the one of the data set from CIMIT, the CIMIT data set on maize from Tanzania 2019. So first, what we try to do, we try to visualize the data set on the map, and then try to download the country-specific infrastructure features, for example, road, water bodies, railway, and so on. So there's two ways. Either we go to the national portal and try to download it. If that is not existing, then we use the OpenStreetMap and try to get the default layers from there. And then we perform the simple spatial join and intersect analysis and try to see how many points are really falling on the road. For example, the below map shows that in the data set, like there was almost like 15 or 20 points that are really on the road. So that is really not good for us. So we reject that point and we clean the data set. So that is like level 1 filtering. Next slide. And then level 2 is really looking at whether the provided data is good or not. In that case, we try to look at it on the high resolution image, but also look some other features. As Ian mentioned, that in GeoWiki, we have the NDVI features. Also nowadays, the Google Earth Engine is developing, and there is many data sets are directly connected. So we select the 5% of samples, try to visualize in the appropriate platform. In this case, I have visualized in the Google Earth Engine, pull the relevant year of NDVI time series and try to map it and see whether it makes sense or not. And based on that, we make the confidence that, okay, the data provided has visually near in the field, and it has the NDVI signature that shows that it may have crop, it is not the forest or water, because each of these features have different NDVI signature. And in this way, we provide the spatial score. Next slide. Yeah, and then temporal accuracy. Temporal accuracy is sometimes tricky because it has a time component, but sometimes the time is actual acquisition which is missing. So it is sometimes estimated date is provided, and that date is either derived from the crop calendar in the given year, or derived from the satellite time, or derived from the submission date. So we take this account and then we try to assign the appropriate score of, on the time. Next slide. And then thematic accuracy is more about explaining the data set. For example, whether it is in the data set land cover, cropland, crop types are present or absent, yeah? Or whether this the validation has been applied in this data set or not, whether like as the crowd or expert, how many percent they agree and disagree with the reporting on the same data set, and finally the classification accuracy, so how much accuracy has been reported or while doing this analysis. So these are all things we categorize in thematic accuracy. Next slide. And then this is a kind of complex tables, but I try to explain it. And this is the overall table. The first table, basically, we have a different data type and then different categories. So geometry, spatial accuracy, level of accuracy of time, and thematic accuracy. And each of these categories have a sub descriptions. So for example, geometry, if the raster data set is reported, then whether it has the 0 to 10 meter of pixel size, or 10 to 20 meter, 20 to 30 meter. Based on that, it gives a scores is assigned. And then each of have justification that why we are assigning that score. And then we have also the weight factor. Because of the mapping exercise, we give the weight of the certain aspect. For example, geometry must be correct. If geometry is not correct, then we cannot have like proper map. So we have a kind of like expert-based weight assignment, and based on that, basically we try to calculate the overall score. So example in the bottom table, it shows for example, field observations. There is 92 and one has 100. Yeah, and LacoWiki, GeoWiki, for example, this crowdsource. In the worst case, if the volunteers is very bad, then the scores can go to, for example, 50. If it's very good, then it can have the 100. So this is just a summary of all the method how we have done. We have developed a very nice calculator basically, so a user doesn't have to do. And this is the final in so far what we have applied in our all data set. So we have seen that though the table is a bit complicated, but like to give you the main message that what we have seen there, field observations are often correct. And it is obvious because the people are going to the field, they are collecting, they have some kind of protocols, and it has been seen that all the field observation and green cell data which we have collected, it has accuracy above 86%. We also look at it the classified map from USDA, and it has accuracy of 78.5. Whereas the parcel registrations, the accuracy varies from 30 to 100, and it is maybe because of different reasons. Yeah, yeah, we don't need to go to the details, but this is like the summary. So the conclusions, what we have to do. So we can see that data reuse is under studied problem. Not many of the movement is more on the fair data principle, publication of data, but there is need for the attention, especially from scientific domain, how we can really leverage the existing data. And it really needs some attention. And second, we present an approach. We believe that it might not be perfect, but we derive some kind of score and assign to an in situ data set. And all this exercise have done in a kind of like transparent manner, and anybody can see it. And if this approach really help us to understand and characteristic and competence of this data set. So how we can use this data set. And the results is still coming, but so far the preliminary results show that this analysis help us to enhance our remote sensing crop mapping product. Yeah, it helps us to select the training samples and also for the calibration and validation of the different remote sensing or machine learning algorithm. Yeah. And the final point which we want to raise that so far most of the metadata miss the quality score. So we believe that adding the confidence quality score in the metadata will or may improve the data credibility and trustworthiness of this in situ data. And that's it. Thank you.
Thank you, Arun. Thank you for that nice overview. Let me stop sharing. So I don't know when we're going to be kicked out of this session. We're all it's almost 10 o'clock. But if there are questions, please raise your hand. Or I'm not sure if I can see anything in the chat yet. So if you have questions, raise your hand, and then we can address those. Kees, go ahead.
Yeah, well, I would like to ask a question how far it has been considered to link to the agricultural services, agricultural surveys, ministries of agriculture, who do extensive crop area, crop yield estimates on season to season basis globally. Especially the FAO supports that through area frame sampling methodologies. And it seems that that component or that connection is a little bit missing. Your comments, please. Anybody?
Hendrik, do you want to tackle that one?
Yeah, I can start and then Sven, you can add.
Yeah.
Well, this World Cereal Initiative is really a global initiative with, yeah, it is very ambitious, but at the same time also modest in terms of resources and capacity. So we really focused on the global, dimension here, trying to get and acquire and harmonize global data sets that are easily available. And I do see your point, because if you can connect to all the different countries and work with them, then you will have yeah, added value and additional data sets. But within the frame of World Serial, that I think was not feasible. But yeah, I appreciate your comment. But Sven, maybe you can.
No, I think you're actually right, Kees. I think there's also a sense of urgency with the data sets that are being collected at the moment. Speed is of the utmost importance. Making that connection with all the national ministries is time consuming. And I think that is something that we can perfectly do within this GeoGlam in situ data working group. There we have through the GeoGlam monitor already connections with quite a lot of the ministries. So there we can make the link. So I think, Kees, you're absolutely right. It is an important link. It was not presented, I think, due to the limited time that we have within World Serial, but also coming from a project, a specific project, it's always more difficult to link with ministries than coming from a community. So I think within this GeoGlam working group, we will be able to have access, well, depending on, because a thing that is not mentioned in this discussion is privacy on data sets and willingness to share some of the in situ data. So that's also things that are very relevant and sometimes slow down the discussion. Okay.
Okay, thanks. Very hopeful. Maybe another small question. When will we cease to be afraid of talking to a farmer and asking him some questions, and put that in the database too?
Well, we're not afraid of that. Absolutely not. And I think what Ian has been showing. Well, one of the two Canadian Ians. Let's say IASA Ian with his tools. It's a first step of talking to the farmers, trying to collect information from the farmers as well, so that they can use the databases. There are a number of initiatives that help farmers already with in situ data and collect in situ data. The interviews, they're also possible. So we're absolutely not afraid of in situ data. I think the other Ian wants to add there a bit. So go ahead, Ian.
Yeah, so I think you hit it well on the GeoGlam front. There are already many activities that are interacting with the ministries. Send for stats, for instance, and the Copernicus for GeoGlam and many others. So through those, as much as possible, we're trying to create a data sharing environment that will allow us to post and make available what is going to be freely available. And then on the, there's a question about being optimistic, and I see this as an evolutionary process. So we can start to build where we can and create that culture of sharing and the value of doing so. And by doing that, it's going to hopefully allow others to realize the value and contribute more. This will take time. But at the same time, there's initiatives. We're engaged in something being driven by the World Economic Forum on data interoperability across the whole agricultural value chain, giving farmers control over their data, allowing them to share at different levels to different parts of the value chain, and also allowing them to possibly add value to their data and make, in some cases, make money off of the value of the data. So all these things are happening. We want, through this working group, we want to be able to harness all that activity that's going on and try to bring some coherence to it all. So it is a huge challenge, but we've got a big committed community.
No, I agree with that, Ian, absolutely. And it's a work in progress, so we're not going to, we have to start somewhere, and it's a slow process. Ian, you just put something in the in the comment there? What was it?
Yeah, just adding to what Kees mentioned, and which is a very good point. Of course, a lot of the stuff we do is not interacting with the farmers, but there was something we did a few years back with CIMIT in Mexico in particular, where we had very much the entire the app was designed exactly with farmers in mind. So it was very much interactive, and there was this sort of two-way flow of information, which is really the next step, where it's not about just asking for information from the crowd or from farmers, but also giving something back. So farmers could get information on weather and climate, drought sorts of issues, also pricing. So we were trying to add a lot of interesting information in there that would be of interest for farmers as well. So this is something we hope to continue with together with CIMIT. So still working on that too.
Okay, thanks, Ian. Other questions? I see we're losing some of the participants to other sessions already. Some people to whom I wanted to ask a question are gone to the next session on Africultures. So, but if there are other questions around the table, please feel free. No, Arun, I have a quick question for you on your presentation.
Yeah.
On the data sharing, I saw that there was quite a lot of white also on your global map, and large parts of Europe were white. Is it just no info, or is it or what was it?
This open data barometer, you mean?
Yeah.
Not sure why, because I took it from open data barometer. We have to check that, yeah.
I found it strange. You had the US very green, and then a couple of countries in Europe were also colored in. But then there were I think the Netherlands, Belgium, they were white.
Okay.
Large parts of Africa were white.
I'm putting the actual link in the chat so that you.
Doesn't matter. I'll have a look. Okay.
Yeah.
Good. So with that, I think we should try to close. So if there are people that are willing to join the in situ data working group, just reach out to me or to Ian Jarvis in that case, so that we can put you on the list. So there's different working groups. You got an overview of those working groups now with Arun on the quality, Ian on in situ data collection, and Hendrik on the reference database. So you can join whatever. If you have great data sets that you're willing to share, please also reach out to Hendrik or to me. And with that, I would like to thank you for your attention.